So, good morning. My name is Cesar, and today I'm going to explain the Quicksort algorithm. Can anyone tell me what's an algorithm? Exactly. In computer science, and in particular, an algorithm is a set of instructions that solve a particular problem. And in this case, the quicksort algorithm, the problem that is solved, is called the sorting problem. And the sorting problem consists in ordering a set of items in a list in a certain order. It could be in ascending order or in descending order. The quicksort is a very famous algorithm. It was invented in 1959. It's still very popular and very used because it is very efficient. Um, the quicksort, it can be used to order any kind of items. But in this case, for the purpose of this class, I will illustrate how it works using an example with an array of integers. So this is an array. It contains 9 integers that are gonna be sorted using quicksort in ascending order. So let's first introduce some terminology that is very specific to the quicksort algorithm. And let's start with the concept of index. The index is just an element, is the position of an element in the array. In this case, for example, the element 22 is position 3 in the array. And another very important concept in the case of quicksort is the concept of pivot. The pivot is an element in the array that is gonna be used to compare with the other elements. And one important goal with the quicksort is that all the elements to the left of the array are gonna be sorted, are gonna be ordered, and all the elements to the right of the array are gonna be ordered. The elements to the left it's gonna be lower than the pivot, and the elements to the right are gonna be greater than the pivot. So to do that, there is a concept of partition. So we have the right partition, that are the elements to the left, the pivot, and the left is the left partition, and the right partition. And we are gonna, yes? Normally, we have only one pivot. We can select the position that we are gonna use to put the pivot. So the pivot can be selected in many different ways. You can select the rightmost element, the leftmost. We can select the pivot as in the middle, but every time the quicksort executes, it will put the pivot in the same position according with some criteria. So we have the partitions, and we define some operations. There is an operation called the swap operation that is just changing the position of two elements. In this case, the element in position 2, in the index 2, with the elements on position 7. If we swap, then the 3 will be in position 2, and the 5 will be in position 7. That's the swap operation. And we're gonna use pointers to the indexes. So let's start applying quicksort to this array. For the purpose of this class, we are going to select the quicksort as the rightmost element to keep it simple. So for us, 13 is going to be our pivot. 13 is going to be our pivot. So we will start with all the elements to the left of the pivot. This is going to be our initial partition, and we are going to start the quicksort. So what we do is to put pointers. It will be pointers to the leftmost and the rightmost element in the partition. In this case, we are going to say, is 17 greater than the pivot? And the answer is yes, it is greater than the pivot. So we keep in that position. Is 3 lower than the pivot? And the answer is yes. So every time the answer is yes and yes, we swap the elements. So in this case, 17 comes to position 7, and 3 comes to position 0. And we move the index. So now the index move to the middle. And we ask again, is 41 greater than the pivot? The answer is yes, so we keep in that position. Is 29 lower than the pivot? And the answer is no. And every time the answer is no, we move the pointer. And we compare again. Is 6 lower than the pivot? The answer is yes. And every time the answer is yes, yes, we swap the elements. So 49 now comes to position 5, and 6 comes to position 41. And we move the index to the middle. And we ask again, is 5 greater than the pivot? And the answer is no, so we move the pivot. Is 22 greater than the pivot? Yes, so we keep in that position. And we start with the other pointer. Is 54 lower than the pivot? The answer is no, so we move the pointer. And every time, remember, every time that the pointers meet, in this case, they meet in position 3 with the 22, then what we're going to do is that we swap with the pivot. We will swap that number with the pivot. So in this case, 22 is going to be swapped, and 13 with 13, which is going to be put in this position. So now 13 is in a correct position. Why? Because all the elements to the left are lower than 13, and all the elements to the right are greater than 13. And what we are going to do is that we will partition. We will make a partition. So we will start applying quicksort again to each partition. In this case, is to the left partition. Let's start 3, 6, and 5. We select as our pivot the element that is rightmost. So this will be our pivot. And we compare, is 3 greater than the pivot? The answer is no. And as the answer is no, then we move the index. Both indexes meet. And when both indices meet, what we say that we do, we swap with the pivot. So now 5 is in a correct position, and since we have only one element to the left and one element to the right, then 3, 5, and 6 are in a correct position. So now we apply quicksort again to the right partition. 54, 41, 29, 17, and 22. Again, we select 22 as the pivot because it's the rightmost element. This is our pivot. And we compare. We set the pointers, and we compare. Is 54 greater than the pivot? The answer is yes, so we stay in that position. Is 17 lower than the pivot? The answer is yes. Every time the answer is yes, yes, we swap these two elements. So now 54 comes to position 7, and 17 comes to position 4, and we move the indexes. And we as a game. Is 41 greater than the pivot? The answer is yes. Is 29 lower than the pivot? The answer is no. So we move the indexes. Both indices meet in the same position. So we swap with the pivot. So in this case, 22 will come here, and 41 will come to index A. So now 22 is in a correct position, and the elements to the left, in this case only one element, and it is in the correct position too. We partition again, so we have to sort this array consisting in only three numbers, 29, 54, and 41. We select 41, the rightmost element, as our pivot, and we compare. Is 29 greater than the pivot? The answer is no, so we move the pointer. Is 54. So in this case, we don't need to compare because both pointers meet in the middle, and what we do is that we swap with the pivot as we did before. So 54 comes here, and 41. Now, every time we swap with the pivot, it gets in a correct position. So now 41 is in a correct position, 29 is in a correct position since it is the only element, and 54 is in a correct position. And now what the quicksort does is that it merges all the solutions. So now we will have 3, 5, 6, 13, 17, 22, 29, 41, and 54. And this is our sorted array in increasing order. So to summarize, the quicksort is a recursive algorithm. Why it is a recursive algorithm? Because it calls itself every time that the array is partitioned. So it calls itself, and it applies the same kind of operation to the partitions. The quicksort is an algorithm that uses the divide and conquer strategy. The divide and conquer strategy consists in dividing a problem. In this case, the problem is the complete array into sub-problems that are easier to solve. In this case, the way that it divided is by splitting the array based on the position of the pivot, and then it solves each sub-problems in the same way, and that's make it very efficient. So the quicksort is very efficient. It's very efficient. It can sort arrays or numbers or lists very big, very fast. The time complexity of the quicksort heavily depends on the selection of the pivot. So normally the pivot is selected randomly, and it is demonstrated that the time complexity of the quicksort when selected randomly the position of the pivot is n log n. And in the worst case, we are not gonna to demonstrate this now, but in the worst case, the time complexity is O n squared for the quicksort. It's the number of elements, and it's the many comparisons that you need to do. In the case of really big arrays, then you will need to reduce the the number of comparisons. So this was a quicksort algorithm.